Hi, in this video, I'll be showing my workflow in bitwig for recording guitars, or really any kind of instrument. And I'll be showing my way of multi-tracking instruments so that one of them's on the left and a second copy is recorded and it's on the right. And then it makes this really wide, rich sound. And I'll be showing some post-processing that I do. And then also for the two takes, I'll be doing some time stretching so that they're really nicely in time with each other and gives a nice natural sounding feel while keeping that really rich, wide sound. But before we get into it, here's the end result. So since we'll be recording the guitars twice, let's just start out with two empty audio tracks, and I will pick my input for that one, and then I'll arm it, and you'll hear me twice. Let's turn that off. Goes off of yellow, then it's no longer monitoring back to you. But let's set up a few things. Let's put on the metronome, let's put on looping, and then it will keep on looping over and over again as I record, and it'll preserve all the takes. Bitwig has a really nice comping feature. Let's go down to just 4 bars. Let's make it very simple for this tutorial. I want to put it a little faster. 140 should be fine. I'm going to point my microphone that I'm speaking into right now down to my guitar in a second. I usually put it 6 to 12 inches away from around the 12th fret of my guitar, and that gives pretty good results. And let's hit record and try to get some good takes. The ending wasn't perfect, but I think it'll be fine. Let's clean up this last part because it overdubs the recording. It keeps on recording over and over. There's this little tail at the end. Let's get rid of that and make it full. And let's skip straight to recording the second guitar. So let's mute the first one and arm the track after picking the input and turn off the monitor. There we go. I'll point this back to my guitar. All right, that take should be good. And I'll just put my guitar away for a second. Okay, so let's see how it sounds already. All right, good. It's pretty similar, but not that interesting. So let's pan one of them to the left, the other to the right, and now see how it sounds. All right, that's actually pretty good. But yeah, one thing that happens when you have two recordings panned left and right is when there are slight time differences, though here it's pretty good. Like this one's a little early kind of thing. You can kind of hear the sound is jumping a little bit to the left and to the right as it plays. And it gives this feeling of sometimes it's a little louder on one of the sides. Sometimes it goes louder left, then right, then right, then left. And just an interesting psychoacoustic thing about that is that's not typically because it's actually louder in the left or the right. What's actually going on there is there's like the Haas effect going on, if you're familiar with it. And the Haas effect is when you play the same sound or any sound, and one copy of it happens a little before on the left, and then it happens slightly delayed on the right, especially in like the 40 hertz kind of a time difference range. Your brain interprets that as directional information. So if it's slightly before on the left, that means that it's coming in from the left. And so your brain says, oh yeah, it's way over there. We don't really want that kind of a difference. We want stuff to sound like it's all one as much as possible. So we want to time stretch all of this as nicely as possible. So what we can do here is we can go into the take that we have and go to onsets, and you can see under onsets, there's all of these. It's kind of hard to see because I don't know why Bitwig made this pink in this case. There's all these blue little flags that got put in, and this is where Bitwig thinks that there's a transient. It put a few too many of them in there. Like all of this I think is a single strum, so we'll want to delete those in a moment. But let's just go ahead. If we right click this and go to quantize, quantize audio. This one gives a kind of advanced dialogue, but the first one just does a quick auto snap. It will actually, it's hard to tell, but it shifts the audio to bring those onsets nicely onto the grid. So let's hear in reference to the metronome how it sounds now. It's probably going to be a little better in some places and a lot worse in some other places. All right, so let's go through and pick and choose which of the changes we do and don't like. We can just go and delete any of the onsets that we don't like. So one thing I notice is that all of this from here and back is a single strum, so we probably don't want stretch points at non-transient moments. And here we can see this comes in a little late, the start of the transients here, so let's pick, I don't know, something a little after and snap that onto the grid. I think that's fine. And again, here, this isn't actually a transient, so let's not put a point there. Because like what actually is happening here is it's stretching the audio around. So we don't want stuff to be squashed and stretched where we don't need it to be. So let's just get rid of this and let it flow naturally. All right, so right about somewhere there, there's a stretch point. I think it did a decent job anyway. Right, this seemed a little early, I think. Yeah, so let's kind of just guess. It's a little better. Here, I don't think. Right about there is where the transient actually happens, so let's get rid of this. And that's good. What's going on there? It's kind of... I think that's okay. Maybe. So it's a lot of just listening, knowing what sound you're dealing with through repetition. Like I know my guitar, I know the little strumming pattern that I'm playing, and I know how it should sound. And so it's kind of obvious to me when something is a little early or late. And so with your sound, it'll be up to you to learn that sound and adjust accordingly. So yeah, here I'm guessing. Yeah, that's all a single strum. So let's get rid of all that nonsense. I think right about there I see. Sometimes you can see where the transient starts, like right there. It's kind of obvious where it starts. But other times it's a little more difficult. Yeah, and that wasn't one. Right, that's too late. That's coming in, so that probably means this is the actual transient somewhere around here, and it needs to be brought back. I'm not totally sure there. All right, I think that's all in a good spot now, and now I just have to do the same thing with the right recording. Go quantize audio, and now it's snapped everything onto the grid. All right, so over to the stretch tab. All right, there we go. I don't like that it's pink sometimes. Yeah, so there I can't see a transient, but what I'm hearing is like pretty close. And it's also a pretty de-emphasized strum, so we can be a bit more lenient on the smaller strums. On the really big ones where I go forte on it, those ones are really important to get nicely on grid because they'll be louder to you when you listen. Yeah, so one thing that you may notice is that when we stretch stuff, it kind of... There's that granular stretched effect that gets applied. And the reason for that is the stretch mode that we currently have enabled is this one, stretch. And it doesn't do a great job on sounds like guitars because what it does, it's like if you're familiar with granular synthesis chops up a sound and then it plays it back in quick succession to give that cool stuttery granular effect. we don't really want that for this. The elastic, the spectral elastic methods work a lot better, especially for guitars. The ones that preserve transients are good. And so Elastic Pro and just plain Elastic do pretty good. I like Elastic. I've had the best results when I've tested stuff. But for stuff like vocals, especially like oohs and ahs, Elastic Eco tends to work really well in my experience. It just depends on the kind of material that you're working with. For guitars, I like this one. So let's set both of these to Elastic Pro. And we should hear a cleaner sound than before. Yeah, so now the whole sound is pretty unified. It was actually a pretty good take to begin with. I've had far worse recordings that I've sometimes had to repair majorly. And yeah, so this is fine. So we can go on to the next step. And really there's just one thing that I kind of always do when I do this multi-tracking. I call it, I don't know if that's even the right word, multi-tracking thing, hard pan left and right sounds that are meant to be unified. So like if I do oohs and ahs, or if, I don't know, if I record electric guitars and pan them, I want them to feel, well, two things. I want them to feel like real and natural for the most part. I mean, there's a time and place for like creative effects, doing unnatural mixing. But I want them to be pretty natural, and I want them to be unified and glued together and feel like it's like one thing. And so just a psychoacoustic thing also is low frequencies typically don't do well with a lot of width. If there's a lot of difference between the left and right channels and the lows, your brain will tend to interpret it as unrealistic. So in like dubstep, any kind of experimental genre, it's fine to do that because your brain isn't expecting natural. But when someone's playing guitar, you probably expect a fairly natural folk acoustic kind of sound. And so, yeah, if you just think about the psychoacoustic properties of like sound, high frequencies, low frequencies, when there's a bass note playing from like a subwoofer or something, the sound is traveling to you, and it travels to your ears. And if a sound is off to your right, it hits your right ear first, and then some of it travels through your skull and into your other eardrum. Some of it bounces off a wall and hits your left ear. With high frequencies, the wavelength of the sounds are so fast that by the time it gets from your right ear to your left ear, it's probably hit like a different point in the phase. Like your left ear is hearing something different from the right ear. But with low frequencies, the wavelength is so long and slow that by the time the speed of sound travels through your head and hits your other ear, not much has actually changed because it takes so long for the wave to change from low amplitude to high amplitude. And so what does that mean? The takeaway is that low frequencies will tend to hit your ears in natural context. They'll hit your ears similarly. If there's a sound coming at you from the left, right, up, down, whatever, it'll hit both ears at the same time. But your brain kind of expects that if there's a bird chirping way off to your right, the sound between your right and left ears will be different. It's just an interesting thing. And so when you have two completely different sets of audio being piped into your ears, there's going to be different stuff going in each ear. And here we have stuff hard pan left and right, because that's what I like doing. And that's fine for the high frequencies, but we probably want to give a natural feel to listeners who are listening on headphones. It's a pretty unnatural thing, actually, to pipe two different sets of sound into each of your ears, respectively. So what you can do to do that, what I have is I have this rack in Bitwig. It's a multi-band width thing. And all it is a multi-band effects 3 device, and each one has a width knob that you can change. And so here I'm just I can just lower the low frequency's width, so it makes the low frequency the same between the left and right speakers. And I might turn it all the way down. Maybe I'd ease it off a bit. It's okay for it to be a little different, but it mostly makes stuff the same. So if we play before this effect, it's like this. And then if I turn it on, it really cleans up all of that like weird, if you're listening on headphones especially, that weird like rumbly difference between the left and right speakers. Like it cleans a lot of that up. It does actually make it a little quieter. But one key thing is it makes it sound natural. I think it makes it sound real, and it also makes it sound unified. It starts to sound a little more like all one sound, even though you've recorded two completely separate sets, like recordings of guitar. So that's something I like to do all the time. And yeah, so that's really the bulk of it. Like, of course, I'll EQ, compress, add reverb, do all kinds of mixing things. On top of that, whatever is needed to suit a track. But this is the core workflow that I go with in Bitwig in order to multi-track real instruments that I'm recording in to microphones into my DAW. So hopefully this is useful to you in some way. Thanks for watching.